Hi, this is Dr. Vikas Paul. In this session, we'll discuss about the shear stress derivation equation. First of all, let us discuss what is shear stress in beams. So in the previous chapter, bending stresses, we have learned that when the beam is subjected to constant bending moment and shear force is 0, then there will be bending stresses in the beam. There are no shear stresses in the beam because it is a pure bending case. Shear force is 0, therefore no shear stresses, only bending stresses will be there. But in actual practice, the beam is subjected to bending moment which varies from section to section, and also shear force is not 0. Therefore, as shear force varies from section to section, due to these shear forces, shear stresses will be set up in the beam. These shear stresses will be acting across transverse section of the beam. These transverse shear stresses will produce complementary horizontal shear stress which will be acting on longitudinal layers of the beam. The formula for shear stress equation is tau equal to Fa y bar divided by I into B. So if for this derivation, let us consider a beam subjected to UDL W kilonewton per meter, and you can see the figure, the beam and a UDL with simply supported beam. Neutral axis, you can see length is L. Due to the load, there will be some deflection. You can see the deflection in this figure. And let us consider two sections AB and CD. So that ABCD of length dx let us consider, and that portion is drawn here, is shown here separately. So let F be the shear force acting on A section AB, on CD F plus df, and on AB let M be the moment, bending moment acting, and on CD let M plus dm be the moment, bending moment. So shear force F and F plus df, bending moment M and M plus dm. And if we see the cross section of this portion, it will be like this. Now let us consider the small elemental strip EF at a distance of y from neutral axis. Let sigma be the stress on portion AB at E, and sigma plus d sigma is the stress on CD at F. Now let us start the derivation. Now, what is the formula for shear stress? Tau equal to F by A. Let it be equation 1. So, area means shearing area. Shearing area means B into dx. A equal to B into dx. Therefore, tau equal to F divided by B into dx. Let it be equation 2. So, F is equal to nothing but integration df, where df is a difference between the force difference between the sections AB and CD. So integration df equal to f. So now what is f? Df equal to fcd minus fab. Next, so what is fcd? So force, we know that force equal to stress into area. So fcd, stress on cd, is sigma plus d sigma. Therefore sigma plus d sigma into dA, and fab, stress into area. So stress sigma into area of elemental strip dA. Let it be 5 and 6. Then from bending equation, we know that sigma by y equal to m by I. Therefore we can write sigma plus d sigma divided by y equal to m plus dm by I. Therefore from here sigma equal to m by y, sigma plus d sigma equal to m plus dm into y divided by I. Let it be equations 7 and 8. Now substitute equations 7 and 8 in equations 6 and 5 respectively. That means substitute equation 7 in 6 and substitute equation 8 in 5. Then we will get FCD and FAB like this. Now substituting equation 9 and 10 in equation 4. Equation 9, this is equation 9, this is equation 9, and this is equation 10. Substitute equation 9 and 10 in equation 4. This is equation 4, df. So df we will get as, so df, on simplifying df we will get as dm by dA by I. Let it be equation 11. Now substituting equation 11 in equation 3, then f equal to integration df integration dm by dA by I equal to dm by I integration y dA, where integration y dA, we know that integration y dA is a y bar. Therefore f equal to dm by I a y bar. So f equal to dm by I a y bar. Let it be equation 12. So substitute equation 12 in equation 2, that is in this equation tau equal to f by b dx. So tau equal to f by b dx dm a y bar by I divided by b dx. So dm a y bar by dx into ib, we can write it as f a y bar by ib, where f equal to dm by dx. We know that for shear force is rate of change of moment. Therefore this is a general equation for shear stress tau equal to f a y bar by ib.